All right, welcome back to nuclear chemistry. So today we are going to deal with the concept of half-life. So I am going to share my screen and let's get into that. So the concept of half-life is exactly what it says. It is the amount of time it takes for a mass to decay to half the original mass. Okay, so if we started at a mass of 20 milligrams, in this case it is a radioactive isotope of oxygen. So if we started with 20 milligrams of that, after one half-life, there would only be 10 milligrams, half of 20, okay? Now, some people think, okay, half-life means we lose 10 and then we lose 10 and we're at 0. No, what we do is we lose half. So half of 20 is 10. Now we have 10 after one half-life. And so now we lose half again. Well, half of 10 is 5. Okay, and then we lose half of that. So we're at 2.5. And so each time we lose half of what we currently have, not half of what we started with. All right, so in this case, if we start with 20 milligrams, how much remains after 1, 2, 3 half-lives? Well, it went from 20 down to 10. Then half of 10 is 5, and half of 5 is 2.5. So the answer would be 2.5 milligrams. Okay, if we look at another one, what is the half-life of a substance in this graph? And the bottom, we always have to examine our graph first. And so in this time, it is time in years, starting in 5,000 year increments. Okay, half-lives are typically very long. Some can be very short, in milliseconds, nanoseconds. All right, in this case, mass of the sample. So if we start with 100 grams, what is half of 100? 50. So that means in one half-life, we lose 50 grams. And we find from our graph, that's about 5,000 years, okay? So in another 5,000 years, we don't lose 50 grams, we lose half of 50. We always lose half of what we currently have. So half of 50 would put us to 25. And then after 3 half-lives, we're at 15,000 years and we're at 12.5. And then 6.25 and so on. So we never ever get to 0. How much of the sample is left after 4 half-lives? Well, let's see. 1 for 5,000, 2, 3, 4. So at 20,000 years, we've come to 50, 25, 12.5, and then 6.25. So 6.25 grams. All right, so that's how half-lives work. It is always half of the current amount, not half of the starting amount. So what I am wanting you to do is go into our nuclear chemistry unit, and part 3 down here is half-life with Desmos. And so you do the Red Bull activity, and there is a link which sends you over, okay, to Desmos and to student Desmos. And at this point, there is a set of slides. You're going to be working on the molecule caffeine, because caffeine disintegrates in your body. It's not radioactive, but it follows the same pattern as a radioactive element does. So you're just going to, in this part of the exercise, fill in some values, okay, that create that inverse curve. So that next point might be down here, and the next point over here and here and here and here. Don't just ram it straight into the x-axis, okay? Make it a nice curve that comes way out over here when you're filling in numbers for this chart. All right, so you're gonna work on that Desmos activity, and then we'll talk about it next time.